Namaskar, hello, and a very warm welcome to this 5-hour online training on developing e-content for teaching and learning of mathematics. I'm Tanvi Khurana, and this entire online training has been organized by Central Institute of Educational Technology, NCRT, New Delhi. This theme is extremely important for this entire training because on day one we discussed, that was yesterday, we discussed the e-content for teaching and learning of mathematics, its need, scope and force. Force, that is free and open source software. And today we are going to discuss GeoGebra, its features and its possibilities. So this is a 5-day training, and every day we come here sharp at 4 o'clock and we discuss one of the topics. Yesterday, that was 21st of August, this training started, and this is going to go on till 25th of August, that is Friday. On Friday, we will give you the link of the quiz and you can participate in the quiz, and you can, if in case you score more than 70%, you will be awarded a certificate. Every 4th week of the month is dedicated for this online training series on developing e-content. So please watch all the episodes that we come up here with, and you can answer the questions of the quiz very easily. I'll show you that how you can participate or register yourself in this particular training towards the end of this program. So please watch this entire program, and if you have any questions, any queries regarding our today's topic, which is GeoGebra, its features and its possibilities, please reach out to us. Either you can call us on our number, which is 8800440559, or you can simply email us. The email ID is one specific email ID, that is training.helpdesk@ciet.nic.in. You're watching us on eVidya channel number 6 to channel number 12, and also on our YouTube channel, that is NCERT Official. In the live chat box, you can raise your questions, queries and share them with us. We have an expert and she is going to stay here with us till 5 p.m. So we have a lot of time for this discussion. Let me please introduce her to all of you. We have with us Miss Sangeeta Gulati. Ma'am, a very warm welcome to you in this program. So ma'am is a National ICT Awardee from Sanskriti School, New Delhi. And I have a lot of questions to ask her. So please raise your questions too within this 1 hour, and we'll be try and take it up towards the end of the program. Just a few more things regarding this online training, and you will be awarded the certificate towards the end of the quiz, but please allow us 30 days for preparation of those certificates. Please have some patience, you will definitely get those certificates for sure. Apart from that, I am going to show you the website towards the end, the entire procedure, so please watch this entire program. Let's begin this program, let's begin this discussion, and just before that, an announcement for all of you. We are extremely proud of the fact that India assumed G20 presidency and would convene the G20 Leaders Summit for the first time in the country this year, that is 2023. A nation deeply committed to democracy and multilateralism, India's G20 presidency would be a watershed moment in her history, as it seeks to play an important role by finding global pragmatic solutions for the well-being of all, and in doing so manifest its true spirit of Vasudhaiva Kutumbakam. Or should I say, the world is one family. Vasudhaiva Kutumbakam also translates to one earth, one family, one future. And that is exactly the theme of this year's India's G20 presidency. Now let's begin this program. Let's understand what GeoGebra is, what are its features, what are its possibilities. So far in this online training we have discussed that how and why is the e-content for mathematics is so important. Yesterday's program was amazing. It was a very interesting and knowledgeable program. So please watch it if in case you haven't watched it. For now, let me please ask ma'am, what is GeoGebra all about, and why is it so important for all our viewers to understand this tool that is GeoGebra? Ma'am.
Great question to start the session here, Tarvi. Again, as yesterday's session very nicely explained why we should bring in technology in teaching, and in especially teaching of mathematics. Teachers' role has changed, as Professor Wazalwa said yesterday again and again, that now the teachers are facilitators of knowledge. At the same time, the subject itself sometimes is overwhelming for our students, and therefore, to make maths engaging, more visual, more fun, technology is helpful. And when we think about technology and subject specific tool for mathematics, GeoGebra tops the list. GeoGebra tops the list for and has been topping the list for many years. Again, looking at how easy it is to use, at the same time, the strength of it lies in the tool being available as an open source. So that is something very, very essential and important. So let's start today's session, and let me, in this 1 hour or almost 1 hour, give you an overview of what this tool is, so that you are ready for the next 3 days, where GeoGebra will be used to teach and to explain the concepts specific to 2D, 3D, and also calculus. So let's get started with understanding what is GeoGebra, right? So GeoGebra, as the word suggests, is geometry, algebra. It sounds like that. So that's where it is coming from. But most important, it's a dynamic mathematics software. And this word dynamic, as we go along, we'll try to understand again and again. And it is suitable for all levels of education, right from the primary to the higher education. And of course, it brings together geometry, algebra, spreadsheets, graphing, statistics, calculus, all in one easy to use package. At the same time, as I said earlier, it's open source, freely available. As Angel ma'am explained yesterday, open source means the source data can be then used and can be changed. So it's available in different languages as well. Many of the Indian regional language and mathematicians from India have authored it in their regional languages. Of course, you can download it. That's again a big advantage of GeoGebra. You can use it, you can carry the software on a pen drive or install it in multiple systems, and it runs beautifully. At the same time, the tasks that we are going to create in GeoGebra and that we are going to use, they are created to enable students to make conjectures which leads to some discovery, which leads to some understanding of the concepts. And that is what GeoGebra is about in nutshell. At the same time, when we look at the concept of GeoGebra, as I said earlier, it's made of, or it is used for, initially it was made for only geometry and algebra, and then other layers get added on. So in one window itself, you can look at a concept and you can think of it in different ways. You can examine it from a spreadsheet point of view, or a 3D, or even a geometric view. So all of that comes together on one single screen, which is amazing. Again, if you are absolutely new to GeoGebra, you must know where to start. So if you would like to work offline, because it does have an online option, and we will be talking about that later, you can download the software, and there are a number of things that are available. So again, go to geogebra.org, that's the website, and there you will be able to, if you see my screen, the number 2 point is the one where it says app downloads, and then you look for GeoGebra Classic 5. Classic 5 is a very user friendly, menu based process, so it's easy to use and it works very well offline. So go ahead and download this software on your systems, whether you are using Windows or Linux or any other software. So once that's there, we are ready to get started. So again, whenever you open GeoGebra, and of course, the icon for GeoGebra, as you can see on the screen, on the bottom right corner, it's the ellipse with 5 points. So maths is everywhere in GeoGebra. We all know that we can construct and define a unique ellipse through 5 points. So that's where this connection is coming in. And when you open GeoGebra, you will be able to see different kind of screens, sometimes depending on the version of GeoGebra app that you may have. But in one screen you will be able to get algebraic view, graphic view, as well as the spreadsheet. So let's, before we move ahead to more detailed components of it, let me show you what it looks like in live, and then we'll come back to the presentation. So this is what your screen would look like when you open GeoGebra for the first time. It might just look completely blank. Don't you worry. If you click on this little, again, there is a little triangle which says graphics. So graphic properties are all saved there, and you can get your axis here, you can get the, and also the grid, and also somewhere here, right on the bottom, on the right edge, you will see a small triangle. If you click on it, you will be able to get the various perspectives. That means whether you want graphing, computer algebra system, geometry, 3D graphics, spreadsheet, probability. That's one way to get the view changed. Other way would be to go back to the menu of GeoGebra right on the top, and you can click on view, and then you can choose which view you want. So in this case, I can choose maybe spreadsheet, and the spreadsheet view also opens on the right hand side. So on one screen, you are able to see so many things. Let's just play with it a little before we get serious about it. Suppose I want to maybe plot a point. So here is a point tool, and again, this session will not take you in depth through all the tools, but we will explore how many of them can be used just intuitively. So do not, hesitate. Start clicking on the tools right on the top, and you will be able to see a point tool. If you pick a point tool and you click anywhere, what I want you to observe is the multiple representation. The moment a point is marked on the algebra view, you can see its coordinates also coming in. So if you are perhaps doing algebraic work or some kind of a graphing work, this might be helpful. But if you are teaching younger children and you want something in geometry, you may not be interested in the graphs. So you can always hide the grids, you can hide the algebraic view, and anything that you're going to do. Very, very important. If you have opened up any tool on the top, you must either use the escape key on your keyboard or go and click on the absolute extreme left tool, which is the move tool. Otherwise, everywhere you click, it will perform the command of the previous tool. So once that's done, then I can maybe hide the axis, hide the grid, and I can have a blank paper just in case I'm interested in drawing some geometric object. So suppose I take a polygon and I want to draw that polygon. Again, you will be able to see that one, when your cursor is on near that tool, it gives you the instructions, what or how you're going to get your polygon. So I want to select all vertices, then vertex again. So closed curve, and it will give you a polygon. So that's the beauty of drawing or getting something like this here. So one might say, okay, why did you open spreadsheet view? So let's take a quick look at how the spreadsheet view can be used along with everything that we have here. So what I'm going to do is I'm going to clean my screen. So one way is I can select everything and I can delete, or I can open a new file, or I can even do Control Z and undo everything. So I'm right now deleting everything that I have here. At the same time, I want to get my axis back so that we also give you an idea of some algebraic expressions as well. So suppose let's type in f of x is equal to x square. I want to get a parabola. So f of x is equal to x square. That's one curve that has been drawn. Again, point tool is available. So I'm choosing the point tool, clicking somewhere on the curve. Now comes the beauty of it. This blue point that you have, if you drag around, it stays on the curve. And in the algebraic view, you can keep seeing that the coordinates are changing,
Ma'am,
right? So what are we going to
ma'am,
do here? Let's do a
ma'am,
quick construction, and then you can tell me what exactly you want out of this. Oh, that's bad. I was sharing the whole screen, right? I had gone for ahead. Okay. All right. Let's see how to fix that.
Okay.
Um, okay, that was not expected. I thought Zoom would pick it up. Tell me if you can see the graph now.
We can still see your presentation. That's what you have opened.
You can only see the presentation, not
Right.
the graph.
No. As in the presentation itself, there is
Mhm.
the slide of multiple representation where the graph is being presented. That's what we can see.
Okay. Let me do this and tell me now. Are you able to see the graph?
Okay. Just
Is this better?
we'll just check. Yes, ma'am. This is much better.
Okay, so we'll go with overlapping screens here
Okay.
and hopefully that would work. Sorry, viewers, I didn't realize because I'm not able to see the telecast alongside, but hopefully you would have tried something. So this is what the GeoGebra screen looks like, and what I've done so far is I plotted a graph, so I'm going to just undo and start all over again. So this is what the GeoGebra screen looks like when you open it once. And what I was demonstrating earlier was going into the view and showing how to get the spreadsheet. So if you go to view and you choose the spreadsheet view, you would be able to get that coming in. I hope, Tanvi, that's visible now.
Yes, ma'am.
It's
Absolutely.
okay. Great. So again, let's try one simple task so that you get an idea of what these various views are doing. So I'm going to just do a slightly faster work, but not going to miss anything. So what have I done? I have just plotted f of x is equal to x square. The moment I type that in, and where am I typing? I'm typing it in the input bar, which is right at the bottom if you are using the classic 5 version. This curve that we have now got, which is showing by default in red, you can change the color, but let's not worry about that. And I want to show the use of spreadsheet along with this view that we have. So I've plotted a point A, which is a moving point on the curve. So if I keep moving this point, you can see that it stays on the graph. Again, let's take a line, and this time I'm taking a special line, which is a tangent to this curve. So if I plot the tangent, it will be points and then curve selected. This is where you've got your line, which is the tangent. Again, very important, as I mentioned earlier, anytime you activate a tool, you must, in a way, what would be the word? Make it inactive. So for that, you need to choose the move tool. So for that, either you press the escape key or the move tool here right on the absolute left corner. Click on that so that you can drag and not keep plotting lines or points or whichever that last tool is. So this is the beauty of what we call as dynamic geometry. You are able to drag things, you're going to be able to pull, you're able to plot, you're able to see various multiple representations. Now let's try to see if we can find the slope of this line. So again, if you go to the angle tool, the sub menu of that gives you everything that you can measure. So let's click on slope and I can click on the line whose slope I need to find. So I've got the slope triangle, that is m is equal to 2.8 is the slope of the line. All I need to now do is to get this data stored in a spreadsheet is to also understand where I'm heading to. If you know what I'm trying to do, maybe put that in the chat. I am trying to build up a calculus concept. So I'm going to bring the concept of slope related to the x coordinate of the point. Point is A. So I'm going to type in within the bracket small x and then bracket capital A, comma, the slope, so that's M. The moment that's entered into the input bar, I get the point B. So let's take a look at what's happening. Keep an eye on this point B. As I move the point A, you can see the point B is changing its position. Can we track what are the coordinates of this point? So only when the spreadsheet view is open and you click on that point and do a maybe right click, you will be able to record to spreadsheet. So I'm going to just record the coordinates of the point B in the spreadsheet. So as I move around, you can see all of them so fast, they're getting recorded. Now comes the big question. What's the connection between the x coordinate and the slope of the line? If you can estimate and guess that, let's hear in the chat. But I'm sure you've understood what happened just now. I've actually plotted the derivative of a function. And the connect is, it's a graph representing 2x, y is equal to 2x. So if I now again do the most important part and powerful part of GeoGebra and right click and I say show trace, trace on, and I slowly move this point, you'll be able to get the line y is equal to 2x. So in one applet, I have demonstrated lots of possibilities, which I'm going to highlight again one by one as we go into various other kind of applets. What I have demonstrated right now is one feature of tracing, the other of dragging, and of course, bringing it all together with the spreadsheet, algebraic, as well as the graphing view. So let's get back to our presentation and try to see what else we can do with GeoGebra. And I would like Tanvi to confirm if this screen is still visible.
Yes, ma'am, it is.
Right, thank you. So again, not to miss out on the possibility that GeoGebra comes with mobile apps, very, very versatile mobile apps, which you can easily download and start using. And of course, the latest is the GeoGebra Suite, which is bringing all of these apps together in one place. So go ahead, download those in your mobile phones, and you are ready to use them wherever you are. GeoGebra, as I love to call, brings math to life. And what you're looking at here are lots of moving images, which is what we are looking at as the dynamic geometry, dynamic figures. And these dynamic figures provide opportunities to our students to experience mathematical possibilities. And what you are looking for is something which our textbooks does not provide. They are extending the concepts, they are bringing maths to life, and they are also opening those wonders of maths, which makes maths so much more magical. Again, the dynamic part of GeoGebra is something which really is to be appreciated. At the same time, what you are need to, and what we all need to understand with GeoGebra is that everything that we do in GeoGebra is a mathematical construction. So when I say it is a mathematical construction, it means that it follows certain mathematical properties. And therefore, it's important to not just believe by looking at it. For example, in this case, this looks like two equilateral triangles. But are they equilateral triangles or not? So if I take you to the, I'm again checking if the screen stays visible when I open something else. Yeah, Tanvi, is it visible?
Yes, ma'am.
Okay. So here is the applet, which again shows what you just saw on my presentation. They both, red and blue, they both are equilateral triangle, or are they? Let's check them out. So if I click on one of the vertex and start pulling it, it's no longer an equilateral triangle. Whereas this one, let's try, pull, drag, move it around, make it smaller, bigger, it stays equilateral. So this one has been constructed. And what are the basic constructions, that steps that have been followed? Exactly what you would do with the compass and a ruler. So this is where the power of GeoGebra comes through. Instead of drawing those arcs which students do not understand, now they are looking at the three sides of the triangle that has been constructed to be the radii of congruent circles. And hence, it is always going to be an equilateral triangle. So this is important for us to know when we think about construction versus drawing aspect of GeoGebra. We will not draw, but we will construct these objects as we go along. So every part of GeoGebra has something for us to discover. At the same time, what's the fun of dragging and drawing or constructing something is where the children start making certain conjectures. They observe and then they make some kind of an observation, deduct, and then try to maybe prove, verify. Of course, first verify and then prove, depending on the level that they are at. So here's one quick look at what the Pythagoras theorem might look like. So this is a construction done to showcase something which the children are able to observe. So GeoGebra works beautifully as a demonstration tool as well. So as a teacher, you might have created this applet. You can project it on a screen, or if you do not have that infrastructure, if you have the file saved on web, you will be able to show it through your mobile phone. You can then ask the children, what do you observe? Take a look at the three squares and their areas. What's the conclusion you can make? And the moment you are looking at that, children will start making certain observations. The main part of the observation is to verbalize it, put it as a mathematical statement, and once that's done, teacher can then bring in the formal theorem and talk about what the result is. So again, these applets either you can create on your own, or you will be able to find some on the web, which is definitely not to be missed, and we will talk about that as well as to where you go, how do you find them. And of course, creating those aha moments in the classroom, those moments where the students observe something and it immediately clicks to them. So that's why this is so. That's what I call as the aha moments, where the teacher is not doing much of an explanation, defining and asking them to write the statement, but by either creating something right from scratch, or by perhaps just observing, the student is able to accept a mathematical concept. That is where again GeoGebra plays an important role. This is one of my favorite applet where the trigonometric functions, which we had taught and learned for years, and especially me who had taught for more than 30 years, suddenly understood why or where this wave-like curve has connected with the point moving around the unit circle. So this is something which is amazing and so easy to construct. I hope in the next 2 days, whenever you encounter trigonometric functions, whether as a pre-calculus or an algebraic concept, you would be able to get a chance to plot this. So this is something which can be done, but of course, I'm not changing the screen with a worry that I might just lose everything, but I'm going to try and quickly, keeping an eye on the time, open another file where I'm able to so I'm not going to save this. And yes, GeoGebra lets you save your files. Let's not forget that you're working offline as I showed right now. So name your file, save it, get back to it at a later time to try completing the task or for using it whichever way. So you can see for today's session, I've saved all of them in a particular folder so that I can keep opening them as I go along. So here is my partially done construction. I have a unit circle, and you can of course change the settings of the x and the y axis. So I've chosen x axis to be labeled as multiples of pi by 2, and I have a unit circle with an arc, and this arc angle is represented by the length of this arc, which is c. So to get a trigonometric function, Graph drawn on a unit circle, what do I need to plot? I need a point whose x coordinate is the angle, arc angle, so C. So generic value, not a fixed number, is to be marked or to plotted. Comma, versus that, I want to see how the y coordinate of C changes because I'm trying to figure out what is the graph of sine function. So in my input bar, which you may not be able to very clearly see, but it's right at the bottom, I'm typing in within the bracket small c because that's the arc angle, comma, y, and then bracket the point which is going to move. So that's the point C in my figure. And I'm going to click at the press enter and I get a point E. Just to make it more obvious for you, I'm going to give it a color. So let's give it a fluorescent green color. Try to make it slightly bigger. So all of this are just the display properties which you can see that graphs allow us to do. So as you move the point C, keep an eye on this fluorescent green. Which curve is it forming? What shape is it tracing? And tracing the point or any object is just a right click, trace on. Let's see if this gives us what you were expecting. Take a look. This is where the point now comes back to 0 and it starts the forming the wave. This is what tracing feature of GeoGebra does for us. So again, if you are excited about this, go and try plotting the graph of maybe cosine function, tan function, and then start exploring more and more. At the same time, you can only type in the input bar just sine x and get the entire wave across the x-axis. Go ahead, experiment with them because this is all about self-learning. Another very important feature of GeoGebra is the sliders. So sliders make things come alive. So I'm going back to the same construction that we did right now. And what I'm going to do is maybe open a new file so that I can quickly show you a little bit of what sliders are able to do. So let's bring our geometric graphing view back in. Sliders are essentially numbers. Anytime you want something dynamic where something is changing depending on the parameter, slider can be made use of. So I'm going to bring in maybe the slider as an A, and here is where I have got that little arrow, and then look for that slider A equal to 2. Click anywhere on the screen, it opens a dialog box. It has a number, it has the values from -5 to 5. You want to change them, you can change them. You can choose the increment to be, say, 0.5. That's how you use the slider, right? So I've got one slider here. And now what I want to do is I want to plot y is equal to, or rather f of x is equal to sine. And I want to understand what will happen if instead of sine x, I had sine of a times x. So a is going to keep changing its value. So I'm bringing some transformation there. So I'm writing a times x and I have the sine curve. But right now this a is 1. So what is the role of the slider? You can drag this around and you can observe the effect it has. So it start asking the question to children, what do you think will happen when a becomes larger positively, negative, and if what happens if I had instead of sine of ax, I had a sine x. So again, if I take f, maybe another function g of x equal to a times of sine x, will it matter? Will it change? What will be the effect? So this is the dialogue that you must have with your students as you start plotting it. Because the moment you press enter or you've completed the function, graph shows up. So they already get the answers, so there's no fun in it. Keep talking to them and ask them, what do you think will happen? That's the fun part of it. So what will happen when a is -5? What will happen when a is 5? What's the difference did you observe? So this is where the discussions can start, and we can talk about, the maximum value, minimum value, maybe bring in the concept of amplitude, wavelength, and you can discuss so many things related to that function or any other concept that you're doing where some variation is coming in. So this is again an important part and the feature of GeoGebra, which you are going to experience in the 3 days that you are we have looking forward to and I've lined up, where each of these features will play a role in discovering certain concepts related to 2D or 3D, and then of course looking at calculus. Also, sliders are used for extensions and explorations. Let's take a look at what this applet does to us. So, if I'm looking at the idea of, Pythagoras theorem extended, I think you did see that in my initial file where we were looking at the changing values of side, and you are able to see a right triangle where the right triangle has now not only squares drawn but regular polygons of n sides. That means the n keeps changing and you kept getting the result still true. So that is an extension of the Pythagoras theorem, which again is possible because we have these tools. Again, once you have demonstrated, ask the students, why do you think the result is true? Is there a connect? Is there a way that you can actually prove it? So that's definitely something important and interesting. GeoGebra also works very nicely if, as a teacher, you want to do a step by step in construction. You can have something pre-prepared, ready with you, and then you can open that file in front of the class, start with a blank page, and then say, okay, step one, we are going to draw a line. And then we are going to take a point. So I'm doing right now locus getting me the parabola. So here is the directrix, that's the focus. So there are check boxes which you can connect together, and with a small condition of if and then, and from there you are able to do a step by step construction. As you click each of the steps, start discussing the geometry or the algebra or the calculus concepts that are running behind it, and keep talking to the children about why you should think this is going to happen, or why is it not behaving the way you expected it to be. So far, all I have done is I have a line, directrix, I have a point called focus, I've got a segment, and I have got a perpendicular bisector. Next, I'm going to also take another perpendicular from that point, connecting the focus to the directrix. Then I get an instruction, drag C. So I have a point C and the instruction is drag C. And we ask the children, what do you observe? What is happening? And then let's trace a certain point. Which point will now give you the locus that you are expecting, and why? So this is where that parabola's definition as the locus of a point, which is equidistant from a given point, which is focus, and a given line comes in place. And students are able to understand. You can also supplement the same activity with paper folding, not only remaining on a digital mode, but having multiple ways for students to learn, right? So that's where we are looking at a demonstration tool. I'm going to skip this one because we're running short of time. So we are going to look at another very important part, because I want every one of you to try and attempt one of these activities on your own today. And that's what we call as GeoGebra on the web. You have a very, very robust website available, geogebra.org. If you have not opened it yet, then do try, check it out, what you have there. And the very first thing you must do is make an account in GeoGebra. Make an account so that every activity that you do offline, you can upload it and save it in your account, so that wherever you are, you can open your account and start using those activities. Secondly, any activity that is available on GeoGebra website, which are more than 100 millions, you will be able to, sorry, not 100, 1 million, over 1 million, you will be able to use all of those activities. So here are how you would be able to get started. If you open up the GeoGebra website, this is how it looks like. And here is where you will be able to find over 1 million community created free activities, simulations, exercises, lessons, and even games, not only for maths but also science. This is the place where you can then start making use of all the resources in the way that you like. There is a search bar, so you can even search for a particular concept. So again, if I put in just Pythagoras theorem, if I just put in Pythagoras theorem, what will I get? I'll get all the apps that have been created by uh, many expert, at the same time some not so expert but enthusiastic mathematics teachers who are sharing these for you. So you can open up any one of them and you are free to use them. You're also free to download them, edit them, and then reuse them. So that is the beauty of having GeoGebra website available, which has community resources. So you can search for a resource, or if you come down further, you will be able to see a nice web created here. Here is where you can start choosing which activity you want. So you can click on geometry, and then all the geometric concepts will start showing up. You can maybe look for something on symmetry. You want to check out what kind of activities they are there. So let's move down, and you will be able to see all of them, whichever you want to use, you're free to make use of them. So again, when I say you can use, what exactly does it mean? How do you use such activities with your students? Of course, as a demonstration, but the other way is to assign a certain task to the students so that the students get engaged with you. So let's try to talk about what is called as the GeoGebra classroom. You are able to use GeoGebra classroom to have live conversations and interactions with these maths tools. So it's basically a place where teacher is kind of following the work of the students. So let's try one of them and see if you can experience that with me in the next 5 minutes. So here are all the tools. These are the new resources that have been shared by Google, by the GeoGebra community just very recently, and they are amazing. So I'm going to try and use one of them, which I really liked. And this is the one which says visualizing algebraic equations using a balance beam. You want students to model equation and then see the connection in terms of how it can be used. Let me first show you what this applet is. So here is an applet where there are these sliders. So what are the sliders doing? Let's try to pull them, and you will be able to see this is for x. So I'm going to model 2x plus 6. So I've got a 2x. Now I'm going to use this slider to get 6 blocks on the second side of the pan, so that this equation becomes, or this side of the pan, balancing pan becomes 2x plus 6. Now on the right side, I want 16 of those blocks. So the moment I bring 16, I get the instruction of solve. So how do I solve now? Again, animate. So this is where your discussion will come in. You can ask the students, how do you want to solve? I have to remove the 6 from the left and then in a way balance it with the other side. So if I subtract 6 from both sides, this is what is going to happen. I've highlighted both, then they kind of cancel out, and then we are looking at 2x, so it becomes a bundle of the 10 that was left is becoming a bundle of 5s, and then one of the bundle will cancel away with one of the x, and you are left with x equal to 5. And you can get new equation from here, and the students can keep playing and experiencing. At the same time, there is a worksheet style questions that can be added. So you can create these worksheets in GeoGebra. And then once you're ready, since you found a beautiful resource and you want to use it with your students, all you have to do is assign this to the students. So I'm going to do that quickly. I'm going to assign it as a GeoGebra lesson. If you are using LMS as Google Classroom, you can assign it in Google Classroom as well. So I'm going to assign it in the GeoGebra Classroom, and I want only the activity to be assigned, not the entire book. And yes, you can create a GeoGebra book as well, which is basically bringing together all these resources. Again, inviting you to try this activity with me so that you get something out of this today's experience of playing with one of the tasks. All you have to do is you have to go to the www.geogebra.org slash classroom and type in this code. I am not too sure if I can put this link, but there is a link that you will be able to generate. You can copy it and you can share it with the students if you are using, say, Google Classroom or any other LMS, or even through your, say, school channel or a WhatsApp. If you put this link in your those various mediums, the student would immediately be able to join. Otherwise, just share this code with them. So I can see one person has already joined. Thank you, Ashwin, for joining in. And you can then get started. So as a teacher, I am able to view from here what the student is going to do. So go ahead, Ashwin, do not hesitate and start off. So the task 1 is to solve 6x plus 1 equal to 91. So just to help the student, I can say, okay, pull the blue slider to get 6x's on the left pan, and then bring a 1 and then start solving it. Whatever I do to Ashwin's panel or applet will not affect what he is doing. And you can see again, there is a feature of hide names. So I can make it anonymous and now play safely. No names coming up on the screen, but if you want your names to be shown, come on, join the game. But this is where the power lies. I am able to track how my students are going to perform, what task they are on, which student has not started the task, and then the second task. So again, these equations are often called two-step equations. Why do you think that is true? So it can be even, for language teachers. If you want a worksheet to be created, as a question and answers, GeoGebra worksheets can be made use of. It can be for science as well. Anywhere you want them to express what they are learning, it is possible. And I can see now so many students joining in. This activity will remain open, but as a teacher, just to show you that I can put this on pause as well. I'm not doing it right now, but I can pause, and I request one of the participants to move over to the task 2. Can you type in an answer for me so that we can look at it, and then we'll stop because the time is going to close for us very soon. So giving you a minute for one of you to come up to the second task, which is basically to answer the question. These equations are often called two-step equations. Why do you think so? So this is fun to watch from here. I can see, everybody trying in a different way, but they're all getting the right answer. And it is becoming interesting to watch 20 of you doing this. So wonderful participation by the audience. So thank you so much for that. So keep playing with it, but I'm just going to again conclude with few things reminding you what we are doing right now, what we are experiencing right now.
Okay.
GeoGebra Classroom, it lets you create these engaging tasks where the teacher gets a live update of what student is doing. At the same time, it works asynchronous as well. I need not be, watching you doing it, and you can continue do it later as well. At the same time, it allows you to give students an applet which is semi-prepared or fully prepared, but the focus is more on the learning of the subject not about struggling with the tool. So that is the important part. At the same time, use the pause button to pause that activity and have a discussion happening in terms of what the students are learning. Why do you think you are doing that? Why are you dragging? Why are you not getting it balanced? What kind of an operation is being used, etc. So that is what GeoGebra classroom is. Again, last but not the least, how do you learn GeoGebra? So if you come to the GeoGebra website, you will be able to see that all your activities, one will be saved for you. Everywhere you click on community resources, if you have created an account, if you go under mine, your activities are created. When I created this activity right now, it's saved in my account. I can go back and see the work of the students. At the same time, if you scroll down this page, you will be able to see right at the bottom something called as Learn GeoGebra. It's going fast, circulating for me, but don't worry, we'll come back to that. So if you go straight down at the bottom of the screen, there are resources, community resources, Learn GeoGebra. If you come to Learn GeoGebra, you will be able to find all these resources, webinars, GeoGebra tutorials, as well as the various other ways you can learn GeoGebra. Through the social media groups, GeoGebra FAQ, GeoGebra has its own forum where you can ask a question, and of course, GeoGebra manual.
Okay.
All of these are available for you to make use of, so that you can keep learning. And that is where I would like to end today's session. Also, we'll look forward in case you have any questions for me, which then we can share. But I hope you have enjoyed and learned something in today's session, and you will continue and extend this learning in the next 3 days.
Absolutely. Thank you so
Tanvi,
much,
any
ma'am. Not just
questions?
a thing or two. I think our students, the viewers, they have learned a lot in this particular program regarding GeoGebra. We definitely have a lot of questions, but because of the time constraint, I can't ask you all of them, but I would definitely ask you a few. So, may I?
Yes,
So
please.
when you ask the students to join the link, is there any limitation of how many students can join the link? And also you said the link, that code will remain open. So is there any time limit for that? It will remain open till when?
Yeah, so good questions. So, one, I have experimented this with more than 200 people at a time. So, no restriction seen so far. Two, if I want to stop the activity, I have to click on pause. So the moment I click on pause the activity, then the nobody is able to come back to it. At the same time, if the participant, the learner, closes this activity and then they open it again, they will not be able to start from where they have stopped unless you have created an account in GeoGebra. If you have created an account in GeoGebra, then your work is saved and you can come back and resume the activity.
All right.
Right?
Yes. Thank you. Thank you so much, ma'am. You have answered almost each and every question which the viewers have asked in the live comment box, and I would not be repeating those questions. But thank you so much for a wonderful presentation. We have got amazing comments, rather compliments for you, that this was a very helpful program, and some viewers were saying that they have used GeoGebra, but the way you explained makes the topic even more clear. Thank you. Thank you so much, ma'am, once again for being with us today.
Thank you.
Thank you.
Thank you so much for having me.
Thank you.
Namaskar.
Thank you to all the viewers for being a part of us, and we can see that more than 3,500 people were watching this program, so it's a great number. Thank you that you really liked this program. Let me please briefly explain you how you can register yourself or participate in this 5-hour online training. Just open any browser and type CIET on it. Once you do, a home page will open. So you can see that this is the home page, and once you see the home page, there is a menu bar, and click on the menu bar you can see home, about us, and projects, resources, events. Click on events, and if you'll scroll it down, the third last option is workshop/training. So workshop/training, click on it. Once you do, another page will open, and once you scroll it down, in the current activity you can see our online training going on, which is on developing e-content for teaching and learning of mathematics. Please click on it once you do, and here is the schedule. Here is all the details regarding this online training, the purpose, the objectives, who all can participate. The entire schedule from day 1 to day 5 has been mentioned, even with the names of the experts. So please keep scrolling, and here you can see the QR code. Just scan this QR code and fill the form. Make sure that you are entering correct information. The spellings of your names should be correct, because that will be used for the certificates. Or you can simply click here, fill the form, and be a participant. If you have not seen yesterday's program, this is the link of our YouTube channel, that is NCERT Official. All the 5 days program will be in this link. So once we are finishing this program, this link also will be added in this particular program. Scroll it down further, and this is the form where you can send us your feedback. If there are any topics that you want us to take in future, please give us any suggestion, any feedback. We are more than happy to receive that. And this is the space where the quiz link will be given to you on 25th of August once we finish our last day's program. So you will get a lot of time to be a part of that quiz and answer those questions correctly. Once you score 70% and above marks, you will be eligible for the participation certificate. And once again, this is our specific email ID on which you can raise your questions even during the program or even later on. training.helpdesk@ciet.nic.in. So here are all the details regarding our 5-hour online training, and today was day 2. Tomorrow will be day 3, where we will discuss developing e-content for teaching and learning of 2D geometry. Sharp at 4 o'clock, we'll come back here on the same platform, that is NCERT Official. So for now, we're wrapping up this particular program, but coming up next is also a very special program called Sahyog, Guidance for Mental Well-being of the Children. And the topic of discussion is going to be choosing a right career, which is extremely important for all the children. Please watch that program and keep on watching eVidya channels. Before I leave, just want to remind you once again that NCERT textbooks for this new academic session, they are available throughout the country. You can either go directly to the sales counter and purchase those books, or you can download the PDF versions from NCERT Diksha or ePathshala website, or you can simply place an order through the website, which is ncertbooks.ncert.gov.in. So thank you so much once again for being with us today. Have a great evening ahead. I'm Tanvi Khurana. I'll take a leave of you. Thank you. Namaskar.